Welcome to another fascinating journey through our solar system. Today, we're exploring the concept of seasons on different planets and moons. We all know that Earth's seasons are caused by the tilt of its axis as it orbits the Sun. But how do the other planets and moons experience seasons? Are they like Earth, or are they something entirely different? In this video, we'll dive into how seasons, or the lack of them, occur across our solar system, from the scorched surface of Mercury to the icy reaches of Pluto and beyond. Let's get started. Let's begin with Mercury, the closest planet to the Sun. Unlike Earth, Mercury has no atmosphere to regulate its temperature. Without an atmosphere, there's no real distinction between seasons. However, the temperature extremes on Mercury are drastic. One side of Mercury is perpetually scorched by the Sun, reaching temperatures of around 430 degrees Celsius, or 800 degrees Fahrenheit, while the other side, forever in shadow, plummets to minus 180 degrees Celsius, or minus 290 degrees Fahrenheit. Mercury's seasons are better understood as day and night extremes, creating a world of sharp contrasts rather than gradual seasonal shifts. Next is Venus, often called Earth's sister planet due to its similar size and composition. But in terms of climate, Venus is a completely different beast. Venus has an incredibly thick atmosphere composed primarily of carbon dioxide, trapping heat in a runaway greenhouse effect. The result? Surface temperatures on Venus stay around 465 degrees Celsius, or 870 degrees Fahrenheit all year round, day and night, with virtually no variation. The planet is shrouded in thick clouds of sulfuric acid, blocking sunlight and preventing the kind of seasonal temperature shifts we experience on Earth. On Venus, every day is a scorcher, no matter where you are. Moving to Mars, we find a planet with seasons that more closely resemble Earth's, but with a twist. Mars has a tilt similar to Earth's at about 25 degrees, and its thin atmosphere allows it to experience seasons. However, due to its greater distance from the Sun, Martian seasons are much longer. A year on Mars lasts about 687 Earth days, so each season can last nearly twice as long as ours. Mars' thin atmosphere means it doesn't trap heat well, leading to significant temperature swings. In summer, temperatures can rise to a relatively mild 20 degrees Celsius or 68 degrees Fahrenheit. But winters are harsh, with temperatures dropping to minus 125 degrees Celsius or minus 195 degrees Fahrenheit. Dust storms are a common feature, often covering the planet and making the Martian seasons even more dramatic. When we venture to Jupiter, we encounter a planet with no solid surface and no true seasons. Jupiter's massive, deep atmosphere, composed mostly of hydrogen and helium, circulates heat across the planet, creating a relatively uniform climate. However, Jupiter does have some seasonal features. Its atmosphere has distinct bands of clouds that vary in color and intensity over time, giving Jupiter a sort of seasonal appearance, even though temperatures and climate remain fairly consistent. These changes are not driven by axial tilt or proximity to the Sun, but by the planet's internal dynamics, including powerful storms like the famous Great Red Spot. Saturn, much like Jupiter, has a thick atmosphere made of hydrogen, helium, and methane, resulting in a cold and consistent climate. But due to its axial tilt of 27 degrees, Saturn does experience some seasonal variations, mostly visible through its cloud patterns and changes in the color of the planet's bands. Saturn's rings, which cast shadows on the planet, also shift with the seasons, adding to the subtle changes. However, despite these visual cues, the planet's overall temperature and atmosphere remain relatively uniform throughout the year. On Uranus, the situation is dramatically different. With an axial tilt of a staggering 98 degrees, Uranus essentially rolls around the Sun on its side. This extreme tilt causes the most pronounced seasons of any planet in the solar system. Each pole gets 42 years of continuous sunlight followed by 42 years of darkness. This creates seasons that are far more extreme than anything we experience on Earth, with one hemisphere basking in sunlight for decades while the other is plunged into a long, frigid night. Despite this, the thick atmosphere of hydrogen, helium, and methane keeps Uranus's temperatures fairly consistent throughout the year, hovering around minus 195 degrees Celsius or minus 320 degrees Fahrenheit with little day-to-day variation. Like Uranus, Neptune has a thick atmosphere of hydrogen, helium, and methane, and experiences relatively uniform cold temperatures due to its great distance from the Sun. Neptune's axial tilt of 28 degrees does create seasons, but they are subtle and take a long time to change. 1 year on Neptune is 165 Earth years, meaning each season lasts over 40 years. While the temperature doesn't vary much, Neptune's atmosphere features dynamic cloud movements and storms, including the mysterious Great Dark Spot, which may shift with seasonal changes in the upper atmosphere. Now let's travel out to the dwarf planet Pluto. Although no longer classified as a planet, Pluto still has a fascinating seasonal cycle. Pluto's orbit is highly eccentric, meaning its distance from the Sun changes drastically throughout its year, which lasts 248 Earth years. This leads to significant temperature shifts as Pluto moves closer and farther from the Sun. However, because Pluto has a very thin atmosphere, its ability to hold on to heat is limited. The result is extreme cold, with temperatures dropping to around -240 degrees Celsius, though they can warm slightly during the summer months when Pluto is closer to the Sun. Lastly, we can't talk about seasons without mentioning some of the fascinating moons in the solar system. Take Titan, Saturn's largest moon, for example. Titan has a thick atmosphere, much like Earth, and experiences seasonal changes due to its tilt and orbit around Saturn. Titan's seasons are marked by changes in the composition of its atmosphere and the flow of liquid methane and ethane on its surface. Triton, Neptune's largest moon, has a thin atmosphere but still experiences seasons. Its orbit is highly tilted, which leads to long, cold seasons. Triton's surface features, including geysers that spew nitrogen gas, may be influenced by these seasonal shifts, making it one of the most unique moons in the solar system. In conclusion, seasons across the solar system are wildly diverse, shaped by factors like atmospheric composition, axial tilt, and distance from the Sun. While Earth enjoys 4 distinct seasons, many planets either have uniform climates or experience extreme, sometimes unimaginable seasonal changes. From Mercury's harsh day and night contrast to Uranus's dramatic decades-long seasons, each celestial body in our solar system offers something unique. Thanks for joining this cosmic journey through the seasons on planets and moons. If you enjoyed this exploration, be sure to subscribe and hit the notification bell for more videos like this. See you next time.